In today's video, here is a nice problem. It's coming from Germany Mathematical Olympiad edition 2000. Here is the following equation. This one is involving three following equations. First equation, we have the square root of x plus y plus square root of z equals number 7. Okay. So the second equation, we have square root of x plus z plus square root of y equals number 7. So the last one, we have square root of y plus z plus square root of x equals number 5. Okay. So obviously the first equation and the second equation are equal to each other because both of them are equal to 7. Okay. Let's go ahead to see how to solve this equation. So basically the first observation that we are going to pick up from these equations. So we have, since we have this equality between first and second equation, so I'm going to put this one equals to this one. Okay, let's do that. So the first thing is coming to our minds. We are going to square both sides in order to cancel this square root. Okay, so let's square both sides. So now it's clearly this one becomes x plus y. For the last term I get also z, and plus the middle term, which is 2 times, is multiplied by z is multiplied by x plus y, like this. Okay, this one follows similarly to the right hand side of this equation. I will have the same thing, x plus z plus y plus 2 times is multiplied by y is multiplied by x plus z, like this. Okay, so the nice thing here, this bunch of these numbers, these three numbers is going to cancel out from the left and the right, and also this number 2 will be cancelled out also. Then I'm going to square both sides. If I'm going to square this one and this one, I get rid of square root, so I get the z is multiplied by x plus y equals y is multiplied by x plus z. Moreover, I'm going to expand this one and this one to see what's giving us. Okay, I get zx plus zy equals yx plus yz. Okay, consequently zy will be cancelled out from the left and the right because they're repeating 2 times. Then I will be left with this nice expression. I will be ended with this following expression, zx equals yx. Okay, now here is a thing. So the common mistake when you divide both sides by x. Okay, if x is different than 0, that's fine, but if x equals 0 is a problem. So based on this one, if x equals 0, we are not going to take this equation at all. Okay, we are going to work on different equation. If x is different than 0, then we work on this equation. Okay, let's take 2 cases. Case number 1, if x equals 0. Okay, if x equals 0, I'm going to plug x with 0 in all these 3 equations. Okay, so I'm going to work on the first equation. So the first equation is giving us square root of y, because x is already 0. Okay, plus square root of z equals 7. So the second equation will be the same. We are not going to repeat the same equation here. So let's move on to the last equation. Last equation, as you put x equals 0, it will be left only with this one. Okay, so I get here square root of y plus z equals 5. Okay, so I have these 2 following equations. So for this one, I'm simply going to square this one and gain number 25 on the right side of this equation. Okay, so I get here y plus z equals 25. So I'm going to leave that as it is, then move over this square root of z to the right and square both sides. Okay, so I will have square root of y equals 7 minus square root of z. Then square both sides like this. I will have y, because y and square root, it will be cancelled out each other. So this one is giving us 49 as a first term, plus z as a last term, minus 2 times this one as a second term, which is 14 minus 14 square root of z. Okay, So the next thing up, since we get this relationship between y and z, so I'm going to put y equals 25 minus z. Okay, I will have here y equals 25 minus z. Okay, then move over these two terms to the left and move over this 14 square root of z to the right and see what's giving us. Okay, so if I'm going to do that, I will have 49 minus 25, which is 24. I get z minus z plus z is giving us 2z equals 14 square root of z, because I have moved this term to the right. Okay, then I'm going to divide both sides by number 2. I get here 12 plus z equals 7 is multiplied by square root of z, like this. Okay, but we still have square root here, so in order to get rid of this square root, I'm going to square both sides like this. So I will get 12 square, which is 144 as a first term, plus 2 times this one, which is 24 z, plus the last term, which is z square. For the right hand side of this equation, I get 49 because 7 square is multiplied by z. I get this square and square root will be cancelled out each other. I will be left with this one. Okay, I'm going to move over this term to the left and simplify this expression to gain a form quadratic binomial equation. Okay, so I get here the following. I get z square 24z minus 49z is giving us minus 25z. Then next up, I get 100 plus 144. The entire thing equals 0. Okay, so the next thing up, since I get a second power equation here, so now without calculating delta of this one as a discriminant, so we are going to factor this one easily. Okay, so we get the following. Get 4 is multiplied by z squared minus 100z plus 144. So we get 144 is multiplied by 4 is given as 576 plus 576 equals 0. Okay, so it's giving us 2z minus 25 here quantity square, like this. If I'm going to distribute this one, is giving us 4z square, which is this one, is giving us minus this one is multiplied by this one is multiplied by this one, we get 100z, which is good to go. Okay, plus the last term, which is 25 square, which is 625, but we have 576. We need to subtract a number in order to get this one. Okay, so we need from 625 to 576, we need to subtract 49. Okay, so minus 49, which is the same as 7 square. Okay, equals 0. So we get a difference of 2 squares here, so I'm going to factor out this one. So by putting this one on the form of the product, I get here 2z minus 32 factor 2z minus 25 plus 7, which is minus 18, equals 0. Okay, so I will have two solutions. I get 2z equals 32, which is z equals 16 as the first solution. The second solution, I get 2z equals 18 is the same as z equals 18 over 2, which is 9. I get 9 here. Okay, so I have extracted two following solutions from this equation. So in order to find y, I'm going to use the last equation with x equals 0. So I already have y plus z equals 25. Okay, so which means I get also y1 and y2 equals y1 is giving us 25 minus 16, which is 9, the other one I get here, I get 25 minus 9, which is 16. Okay, so I get as a first pair of the solution, which is x equals 0, because we have built these solutions based on this value of x. Okay, so I get this y corresponds to y1, which equals 9, and z1 equals 16. The second pair of the solution, it will have the same value, which is x equals 0, and y2 equals 16, and z2 equals 9. Okay, so I have extracted two solutions from the first case. Now let's move on to the second case, when we have x is not equal to 0. So basically this equation was found before, so now I'm going to continue working on this one now. So by dividing both sides by x, because we have x different than 0, so this one is giving us y equals 0. So now I'm going to work on this information. Now plug in z with y in these three equations and solve the equation. So I get the first equation, which is x plus y plus square root of y, because z is already replaced with y, equals number 7. Okay, then the second equation, so we don't have to repeat the same equation because this one is the same. So let's move on to the second equation. So the second equation, I have 2 times y plus square root of x equals number 5. Okay, so we have y plus y. As you replace z with y, you get y plus y equals 2y. So now I'm going to move over this term to the right and square both sides. So I get here x plus y equals 7 minus square root of y. Then square both sides like this. I get here 49 plus y as a last term minus 2. Minus 2 is multiplied by 7, which is minus 14 square root of y. Okay, this one equals x plus y. So the nice thing here, when we get y, will be cancelled out from the left and the right. I will be left with this expression. I get x equals 49 minus 14 is multiplied by y, square root of y. So I'm going to make the combination between this equation and this equation. We have square root of y, but we have square root of 2y. So I'm simply going to multiply both sides by square root of 2 in order to get the same thing. So I get here square root of 2 is multiplied by x equals square root equals 49 is multiplied by square root of 2 minus 14 is multiplied by 2y. Okay, this square root of 2y will be replaced with this one, 5 minus square root of x. So I get here x is multiplied by square root of 2 equals 49 is multiplied by square root of 2 minus 14 is multiplied by 5 minus square root of x. Okay, so I'm going to make the simplification here. I get here 49 square root of 2. I get minus 14 is multiplied by 5, which is minus 70, plus 14 is multiplied by square root of x. Okay, then next thing up, I'm going to put this one as a capital A. Okay, let's put it here. Capital A equals 49 square root of 2 minus 70. Then the next thing up, I'm going to move over this capital A to the left and square both sides. I get x square root of 2 minus capital A equals 14 square root of x. Then square both sides. This one is giving us 14 square, which is 196. X equals this one equals x square is multiplied. I get 2x square because I'm squaring this one. minus 2 times a is multiplied by this one, which is minus 2 capital A square root of 2 x plus the last term, which is a square. Then next thing up, I'm going to move this term to the left and make x as a common factor. So I get the following equation. I get 2x squared minus, I'm going to put this minus number 2 as a common factor as well. Minus 2 is multiplied by capital A square root of 2 minus this one becomes plus because we already put minus 2 as a common factor, and then dividing 2 by this one by number 2 is giving us 98 minus plus 98. The whole thing is multiplied by x plus the last term, which is a square. The whole thing equals 0. Okay, so I have this nice form, a quadratic polynomial equation. Let's put this one as a capital B. Okay, so I will have a simplified equation. I get 2 is multiplied by x squared minus 2 times is multiplied by capital B is multiplied by x plus capital A squared, which equals to 0. Okay, now we are simply going to solve this equation by calculating the delta of this one, discriminant. So in order to find this value B, you are going to calculate capital A, you get a value, then calculate capital B based on the value of capital A, then find the delta and find the solutions. You will have two solutions. Okay, so then you will find two solutions, x1 and x2. x1, one of the solution, it will be impossible because you exceed the value of this one, the sum of these two terms. Okay, then you will have only one value of x, so I'm going to put the x value here and y value. By calculating this one, you get x equals 13 over 5,000, and you get y value equals 49 over 4. Okay, so with z equals 49 and over 4 because they have equality. So I get this pair of the solution is when we have x different than 0, and then I get the first two solutions when we have x equals to 0. Okay, so this is the only values that I will have for this equation. So if I undo this video, if you have any question regarding this problem, just put it in the comment section below. If you have any other suggestions, just put it in the comment section as well. So by the way, don't forget to hit the subscribe button and support the channel. And thank you for watching. I will see you in next video. Bye.